I will start the training course and the presentation now. I welcome all attendees to the ICPDAS online Win-GRAF training course. Thank you for showing interest in our Win-GRAF products and joining this course. My name is Martin Kruschardt, and my department at ICPDAS is responsible for the EtherCAT and Win-GRAF product line. The main purpose of the Win-GRAF training course is to introduce the ICPDAS PLC series and show you how to program a PLC application using the Win-GRAF Workbench. During the training course, the Workbench programming editor for implementing a PLC project and tools for debugging, monitoring, and troubleshooting of an application are introduced. Today's course is the first course among many, and in the future, for each PLC controller type, a separate training course will be provided. Today's online tutorial mainly shows you how to get started with the Win-GRAF Workbench. In the first part, we will give a short introduction into the Win-GRAF and its key features. In the second and the third part, we will list the hardware and software needed for following the hands-on training course and to implement the project example yourself. And in the fourth part, it's our hands-on training, which shows you how to write a simple ladder diagram and run it in a virtual PLC, and shows you how to configure our ICPDAS WinPAC controller and its local IOs and control the IOs with a simple ladder logic. And last, we will show how to protect the PLC application on the WinPAC controller with a password so that it cannot be accessed by an unauthorized person. Now, a short introduction to Win-GRAF. Win-GRAF is ICPDAS integrated development environment. And for programming PLC application and it meets the international standard IEC 6131. It basically consists of two parts. First, it's the Win-GRAF Workbench, and then the runtime. The Workbench is a PLC programming software for programming our PLC series, and its development environment is purposes for designing, programming, and configuring, debugging, and maintaining machine applications. And the runtime is installed directly on our controller and is basically the operation system on which the compiled PLC application is running. So the runtime is necessary in order for the application to access the hardware, the controller hardware, such as local IOs or memory, or access the communication interfaces for remote fieldbus communication. So the runtime is adapted to the controller hardware and is factory installed. Now to our Win-GRAF Workbench. As I already said, this workbench is used for programming PLC applications. All 5 programming languages defined by IEC 6131 are supported, like structured text, function block diagram, ladder, etc. These are the same programming languages used by codices. So all programming languages supported by codices is also supported by the Win-GRAF Workbench. In addition, the Workbench supports several programming languages in the same application project. So you can use several programming languages in the same application. And in addition, the Workbench provides function for converting an existing program into another programming language. And it also supports function for comparing different projects and allows the user to create their own user library. The new Workbench version supports multitasking programming with priority setting. And in addition, extensive libraries are provided for reducing the development time and simplifying the application implementation. Different Win-GRAF controller can talk with each other via the local area network by using the data binding mechanism. So that Win-GRAF controller can exchange data via the local area network. In addition, programming interfaces are provided for Windows-based application like LabVIEW or Visual Studio written programs to directly access the application on our controller. In addition, extensive programming help and documentation are available to familiarize yourself with the Workbench environment. The Win-GRAF Workbench development environment comes with plenty of tools, such as online monitoring, debugging tools, and configuring tools, etc. Some of the tools will be introduced today. This slide shows the different PLC types provided by ICPDAS. ICPDAS provides a variety of PLC series, which differs in size, form factor, CPU, operation system, etc. So the main field of application is a little bit different for each PLC type. Some focus on compactness or simple I/O control, others on flexible I/O adaptation, and others on speed and real-time control, and others again, the main field of application is motion control, like the devices shown on the bottom of this slide. Today's online training focuses on the Win-GRAF controller series, which is currently our best sold PLC series. In the future, the other controller types and their main features will be introduced in more detail. So if you need additional information about our PLC controller types, just go to our website. We provide tables comparing the functionality of each PLC type. Most of our controllers are equipped with expansion slots to expand the local IOs. ICPDAS provides a large variety of IO plug-in modules, such as digital, analog input. In addition, we provide expansion slots for communication expansions, such as serial USB and Ethernet port extension. The Workbench has got an integrated tool for configuring the expansion modules, which we will show today how to use this tool. This slide, for example, gives a quick overview of all the ICPDAS I/O plugin modules provided by the Win-GRAF series. As you can see, the product portfolio includes a large variety of digital, analog, in and output modules with different channel numbers. Analog output modules, in and output modules are available for example, voltage and current measurement, strain gauge, temperature measurement, thermocouple and RTDs, etc. So the Win-GRAF series with the I/O expansion slots are very flexible and can be easily adapted to your needs or to the industrial application, the requirement of your industrial application. The several fieldbus communication protocols are supported by our PLC controllers. All PLC controllers support Modbus, TCP, RTU, UDP, and ASCII. In addition, it supports multi-master and multi-slave functionality. The one PLC can act as a multi-master or multi-slave. This allows you to control several separated Modbus networks. EtherCAT communication, which is the main communication technology for our motion controller, is supported by Win-GRAF. In addition, Decon protocol, which is ICPDAS proprietary communication protocol for our serial fieldbus devices, such as the i7000 series. Most of Win-GRAF controller comes with a built-in OPC server that can transmit PLC data to a remote OPC client, such as HMI or cloud data centers. The Win-GRAF platform comes with a human-machine interface support for designing graphic control panels. Currently, 2 HMI versions are available. The E-Logger, which is ICPDAS in-house developed HMI software. This E-Logger includes a web server HMI, so you can design a web server HMI with this environment. And we support Aviva Edge, formerly known as Indosoft. Now to the hardware configuration, to the hardware used for the hands-on training today. For this demo, we use the ICPDAS 4-slot Win-GRAF controller, as shown here on this slide, which to control its local I/O plug-in modules. This controller has got 4 expansion slots. In the first slot, we will insert a 16-channel digital input module. This is shown here on this slide. And in the second slot is 16-channel digital output module. And in the third slot, a 8-channel analog input module. And in the last slot, a 4-channel analog output module. Below are links to the website of each module. So you just click this link to open its website and get more description about the plugin modules. For the purpose of this tutorial, the first 8 channels of the digital output modules are directly wired to the digital input modules, first 8 channel digital input modules of the digital input module. This allows us within the application, within the PLC application, to directly confirm the output setting by just reading the digital input status. In addition, 6 LED lights are directly connected to the digital output channel 8, 9, until 13, and 3 press button switches are being directly connected to the digital input module channel 8, 9, and 10. The same wiring procedure has to be implemented with the analog input and output module. The analog output channel are directly connected to the analog input channel. So the first 3 analog output channels are directly connected to the analog input channel of the analog input module. And in this way, the analog output values can be directly verified within the logic program by reading the analog input values. And the fourth and the last analog output channel is directly connected to a voltmeter to show the current voltage output. Additional communication setting have to be done. Due to time restraints, the setting procedure will not be shown. Plus, just refer to this slide for the configuration procedure. Basically, each WinPAC has a factory installed PAC utility. Just start the PAC utility, go to the IP config tab, and insert a static IP address, the static IP address of the remote module. Just make sure that the local area network setting is correct. Otherwise, the workbench will not be able to connect to the remote device. In addition, just confirm that all the I/O plugin modules have been correctly detected by the system by just opening the PAC utility and go to the module multi-I/O module tab and check whether all the modules have been correctly detected and have been inserted in the correct order. Now to the workbench, Win-GRAF Workbench installation. The Win-GRAF Workbench can be directly downloaded from our website. Just enter the keywords Win-GRAF Workbench into the search bar of our main website to open the Workbench website and click the download center to download the Workbench. In addition, if you want to use the fully licensed version, you have to buy a USB key from our sales. As I already said, the Workbench is USB dongle licensed. The fully licensed version comes without any limitation. It supports an infinite large number of I/O points. The Workbench automatically starts as a trial version, as shown here on this slide. If it started without a USB dongle, so any PLC application compiled by the trial version will only run for about 50 minutes. After 50 minutes, the application automatically terminates. Now to the hand-on training. In this training, we will show how to create a project, how to run a simple ladder program inside the simulator, how to configure our I/O plugin modules and mapping PLC variables to the physical I/O channels, and run the application on the remote target, and show some workbench debugging and monitoring features. And at the end, we will password protect the remote application to protect it from unauthorized persons. So this is after the workbench has been started. It starts with a welcome page. This is the workbench screen after once it has started. So the workbench opens with the welcome page, which allows you to easily access basic function. First of all, the user language can be set by just clicking help language, and we provide support most of the European language. In addition, some Asian language like traditional Chinese and Korean. Help files can be opened with F1. You just have to enter any keyword or topic or name for which you need more information and documentation. Tutorials are provided. Just go to the help file and open a tutorial. These tutorials are all in PDF format. You can also directly go to the tutorial directory where all the tutorials are listed and shows you how to get started, how to write create a PLC project, create a simple logic diagram or logic program. And demo programs are provided by just clicking one of the demo names. This white pane on the right just lists all the recent projects which you can open by just clicking on one of the names. In addition, we provide link to our websites. Just this is the first Win-GRAF website link. Just opens the main Win-GRAF website. The also Win-GRAF frequently asked question website link are provided. In addition, if you need service or technical information, just contact our support by just clicking the contact us link at the bottom of this welcome page. Now we show how to create a new Win-GRAF project. To open the Win-GRAF project, we have to click this green single task project button. This will open the project wizard, which guides you through the process of creating a project. We first have to highlight the project item. Then we have to set a destination folder where to save the project, and then we set a project name. We just use tutorial 1 and click. And then you have the option to comment this project. Just add a comment for which the purpose of this project or the main field of application. Then go to next. In the next step, you just have to select the programming language you want to use. As I already said, we support all 5 programming languages defined by 61131. We just use a ladder diagram. The debug compiler, we leave the compiler option in debug mode, which allows us to use breakpoints and step-by-step debugging. In the next step, we have to set the IP address of the remote device. Please leave the port address to 1100 because this is the default standard port number used by our workbench to connect to the target device. All the other settings leave at the default. And then go to next. These items are not critical at this point, so these items we leave at their default setting and just click finish. So this is now a project has been created. Remember that all settings done in the project wizard can still be altered after the project has been created. So just let's have a look at the workspace. The top name of the workspace lists the tutorial as a project name. And under program, the folder program, the individual programs developed for this project are being listed. The default program is called main. You just click it and the programming editor will open where you can edit your logic program. In addition, the watch folder stores all the monitor and troubleshooting items like SPI list, soft scope, etc. Just, for example, we can directly open the soft scope by just double clicking it. And I'll show you later on how to use this tool. And last, the variable item, which lists all the items created for this project. The remaining folders are not important for this course right now. Okay, now let's start writing a PLC application. First, we have to set the cycle time. We click on the project name, right click on it, and you select setting option. And then we just double click the cycle time entry, and we will set the cycle time to 10 milliseconds, for example. This cycle time means that in fixed time interval of 10 milliseconds, the project main will be executed, will be triggered to be executed. So every 10 milliseconds, this main program will be executed inside the target device. Just click OK, confirm the setting, and close the window. Now we will create our first simple letter diagram application. We double click the main program. Now we will add a rung to the program editor. On the left margin of this program editor are all the tools listed which are necessary to edit or to create a PLC letter diagram. We will add a letter diagram, a letter rung just by clicking the insert rung button on the left toolbar. Now a rung, basic elements of a rung consist of a contact and a coil. We now have to link this contact and a coil to a variable, which means we have to create a variable. The variable editor is on the right-hand side, right pane. And we have got three types of variables. The main, global variables, and retain variables. Global, these variables, these types just define the scope of each variable. The global variables can be accessed by all the programs in the project. The retain variables are also global variables, but in addition, they are saved to a non-volatile memory in regular time intervals. So during a restart of the application, the retain variables are initialized with the last values before the application stopped. And then we have got the local variables, which are only accessed in the local program by one program. It cannot be accessed by other programs. The procedure for creating a variable is for all data types the same. Now we will create a new variable. We just right click. We will create a local variable. We just right click the local name and click add variable, or just click or press the insert button on the keyboard. And now we will assign this variable a name. We will add this variable, assign this variable to the contact element. Therefore, we will call it set alarm. Okay. Now, in the next step, we have to set the data type of this variable. Just double click the data type field, and all the data types supported by 61131 are being listed. In addition, function blocks and also structure, etc. Because this is a contact can only be true or false, on or off. Therefore, we have to select the bool variable data type. In addition, we have to set its initial value. We want the contact to be set to off when the program starts. Therefore, we will enter 0 to it, and the variable will be initialized to false once the program starts. Now we just drag this variable on top of the contact to link it to the contact. The same procedure we will repeat with the coil. We again insert a new variable. We call this variable alarm light 1. This coil will be linked to represents a light, for example, and click OK. A coil does not need to be initialized, therefore we don't have to add an initial value here, and we just drag the variable on top of the coil. We can increase the zoom in and zoom out to make it more visible. Now, we want this alarm light to flash or to blink every 2 seconds, where we have to add a blink function block before the coil, alarm light coil. We just select the position where we want to end the function block and go to the function block tool command, just press function block, and a function block will be added. Now we have to select the correct function block name. We double click the function block, and we want to search for the blink function block. We just add DL, and the list will automatically jump to the blink function block. Just double click it, and now you can see this. An instance of this function block has been created. The instance name is being shown on top of the function block, and in addition in the variable editor. Now we have to set the flash time, the blink time. Just double click the entry, and we set the flash time to 2 seconds. Press enter. Now we don't just want to control one alarm light, we want to control several lights. This we can do by just clicking the coil and adding to the coil parallel coils. We add additional 2 coils, and we will create for each coil a new name, a new variable. Okay, and another one. Now we just again drag this name on top of the coil to link it with the coil. So this is our first ladder program. Now we have to compile this application. We have to go to the build icon, click on the build icon in the toolbar, and you have to make sure, double check whether the build process has been completed successfully. No errors were detected, which means no, the build process was successful. Now we can run this application inside a simulator. Simulator are used for simulating PLC operation on your personal computer in a virtual mesh PLC. So the simulator virtual PLC runs directly on your PC, and it allows the programmer to test and debug the PLC application logic before downloading it to the controller, to the real controller. To run this program in the simulator, just click on the simulator button in the toolbar and cold start the application. The run on the top of the toolbar indicates that this PLC application is now running inside the virtual PLC on top and on your PC. Now, in addition, the inline monitoring function is enabled, which shows current value for each variable, shows the current value in the ladder editor as well as in the variable editor. Now we can force this contact to true by just double clicking on it and selecting true to start these lights to flash. Now we will see after a while these 3 coils which represent a light will flash. True values are being shown in red and false values are being shown in blue. Now I will show you how to create variables directly in the ladder programming editor. In order to change the PLC application, we first have to go offline. This way we set the simulation mode off. Again, we create a new rung with the basic elements of a contact and a coil. Now we will directly inside the ladder programming editor, create a variable. We just double click the coil and enter a new name. For example, we use this set warning for this contact and click OK. Now a new dialog pops up where you again can select the data type. Because this is a contact, we leave the setting to bool. In addition, you can set the scope of this variable as a main global, as a local, global, or retain. We leave it as a global variable. And because it's a contact, we have to set initial value, which we will set to false. Clicking yes will show the new variable name on top of the contact. In addition, it will be shown inside the variable editor with the initial value. The same procedure has to be can be done with the coil. We use a coil, for example, assign it to a warning light. 1. Okay. A coil does not need to be initialized. We just leave the default setting. Again, the coil, the new variable name is being shown in the variable editor and also on top of the coil element. Now we want again this light to flash every, for example, 3 seconds. But in this example, we will directly go to the function block library. We just select the block tab, and all the function block libraries supported by the Win-GRAF are being listed here. You can again select the blink function by entering the first 2 letters of the word of the name of this function block, and then we just directly from the function block editor drag this function block directly to the position where we want to appear. Now, again, function block instant is being created, automatically being created, instant blink, and also being shown here in the variable editor. We will again control several lights in parallel. Therefore, we have to again add parallel coils, and we just call them warning light 2. Confirm the setting and warning light 3. Yes. So then all the variables again will be shown, also shown inside the variable editor. We can sort them alphabetically to have a better overview of the created variables. Now we will have to compile the program again. Just add compile. And as you see, a compile error has been generated. We can compile errors are being shown in red. We just double click the arrow and the Workbench will immediately show you where the compiler shows you where he found the error. In this case, we haven't assigned a constant value to the function block blink. It means we haven't assigned him a time interval. You just double click the input and again select a time interval, for example, of 3 seconds. Again, build the project again. No errors are detected. Build process was successful. Now we will go again into simulation mode. Cold start the application and just double click the coil and set it to true to force the lights to flash. So all the values of the variables can be directly controlled or monitored inside the ladder editing program and also inside the variable editor. Now I will show you how to configure our plugin modules. We will have to leave the simulation and open the plugin configuration interface by double clicking the IO icon on the toolbar. This is the new I/O configuration user interface for our Win-GRAF Workbench 11 for configuring the local I/O expansion modules of our ICPDAS PLC controller. The I/O configuration method has been changed from the previous version. The previous version, the I/O configuration, in the previous version, I/O configuration was not so convenient. The new graphic interface provides a more convenient and simplified form of I/O configuration and variable assignment. This user interface is more intuitive to use. I will show you how to use it. In the following steps, first, it is necessary to select the correct target platform. Our controller type, just double-click the name on the left bottom window. And this lists all the controller types supported. We will today control the Win-PAC 8000 series. Therefore, we double-click the VP8000-CE7. And as you can see, after selecting the PAC type, the controller type, the upper window will show the figure of the main control unit of the Win-PAC. In the right pane, all the I/O modules are being listed, which are supported by this controller type. You can directly add an I/O module directly to the controller type by either dragging it to the left-hand side or just double-click it. You can add up to 4 modules. I/O plugin modules can be removed by just right-click a module and click remove, or just press the delete button. Now for today's tutorial, hands-on tutorial, we will first, in the first slot, we will insert the 16-channel digital input module 8052. All the I/O modules are categorized into different types, for example, digital input, digital output, analog input, analog output, for easier or faster, quicker access. Then in the second slot, we will go to the digital output. We will add a 16-channel digital output module. Just double-click it. And in the third slot, we will add a 8-channel analog input module. And in the fourth slot, we will add a 4-channel analog output module. So now it is necessary to create and assign for each physical channel a variable so that the PLC logic program can directly read the input status and control the output of each channel. For this, we will therefore for each module create an array and map each array element to the individual channel. We will define this array as global variables. We will insert and name this first array 8053. And this is a digital input module, and we just add a DI to indicate it's a digital input module. It's an invalid name. We have to check. Wait a minute. Now we have to make sure select the correct data type, because it's a digital input. It can only be on or off. Therefore, it's a bool data type. Next, we set the dimension of the array. This digital input module has 16 channels. Therefore, we will create an array with 16 elements. Let's enter 16. And in the next step, we will drag this array directly to the first digital input channel of this device. And now you can see each variable, each array element is automatically connected or has been mapped to the digital input, physical digital input channel. The same procedure we will repeat with the digital output module. We create a new digital new variable, an array again. It's a digital output. Just enter. Again, digital output, data type is bool. This module has 16 channels. We enter an array, create an array with 16 elements. And in addition, we want all the channels to be off during the program start. Therefore, we just double click the initial value column and select all the elements in the array and initialize them to false. Close this window, save the setting, and here you can see all the 16 elements of this array are initialized to false. Now again, you just click this module, the digital output module, and just drag the array to the first channel of the digital output module. And again, the Win-GRAF Workbench, the tool, will automatically map each array to the physical digital output channel. Now we come to the analog input module. Analog input module requires additional configuration. Let's just double click the module, go to the analog input tab, and now you first have to set the physical unit to measure and its range for each channel. Just double click the channel and the supported options are being listed. We just leave the setting to plus minus 10 volts. And in addition, you have to set the value format. 2 value formats are supported, the engineering and 2 complements. We just leave the default setting. This has to be done with each channel. We just leave the default setting, close this window, create a new array. This is the analog input. And now we have to be careful. It's the data type is a real as shown here. Therefore, we have to change the data type here as well to real. We want to control 4 channels. Therefore, we create an array of 4 elements. And again, we just select this module, the analog input module, and just drag the array to the first element. Now you can see this analog input module has got 8 channels, but we just assigned 4 elements or 4 variables to the first 4 analog input channels. The remaining channels are being indicated by 3 question wirecard characters, which means these channels are being ignored by the compiler and the PLC application. They will not be used in this application. Now we go to the analog output module, double click it again. Again, we have to set the physical unit to measure and its range. It's just 2 options are only available for this module type. We just also leave the default setting. And again, the value format has to be set. Again, we leave the default as a default setting. A new array has to be inserted, created. Output and enter confirm the name. Again, we have to set the data type to real, as shown on the bottom. And this module has only got 4 channels, therefore we create an array with 4 channels, 4 elements. And in addition, because it's an analog output module, we have to set the output values during the program start. Therefore, we double click the initial value, select all the elements of this array, and select the output voltage value 0. Close this window and confirm the setting. And here again, the initial value indicates that all 4 elements has been initialized to 0. Now, although the logic of this program does not currently at this stage does not access the local I/O points, the application can still be compiled and downloaded to the remote WinPAC, which allows us to directly monitor each input and output channel directly. Therefore, we will compile this project, this application. No error has been detected. Compile process was successful. Now we have to download this program to the remote WinPAC controller. We just double click this offline in the status bar, this offline field on the status bar, and have to set the remote IP address. But this I have already set in the project wizard, therefore I don't need to set it again. We just close this window, download this application to the target platform by going to the download button in the toolbar. And after we have downloaded it, we just create a online connection to the remote. Again, the run indicates that the application is now directly running on the remote controller on our WinPAC controller. In inline mode, all the status or the values of each variable, as I already mentioned, are shown next to each variable. For example, here you can see the current status of each digital input and output module, as well as the analog input and output module. The analog input, but the analog output module currently does not show any values. Why? Because we have forgotten to map this array to this digital, to the physical analog output module. This we have to repeat, therefore we just click this module again and just drop this array which we have just created before and drop it to the first analog output channel. And now all the analog output channels are directly mapped to a variable. Again, we have to compile this project, download it, and go into online mode. Again, the inline monitoring function is being activated, which shows each value for each variable. And here you can see now the current analog output setting is being shown. So a standard PLC application consists normally of hundreds of variables, and therefore we will use the SPI list to allow us to just monitor a selected number of important variables which are critical for the application. So in this demo, I will show you how just to monitor the analog and digital in and output values of the plugin modules. We will add a new SPI list to this project by right-clicking the watch folder and going and selecting the SPI list from the list provided here. Go to next. We leave the default SPI name, and after the SPI name has been added to the workspace, we just double-click it, and now we will directly watch the physical analog and digital input and output values. You just drag all the arrays directly into the SPI list. Open, for example, the digital input array and the digital output array. Now, as I already mentioned before, the first 8 digital output channels are directly connected to the first digital input channels of the digital input module. Therefore, by just double-clicking one of the elements, we can force an output value. Just click true, and now No, it's not showing any values right now. I have to wonder why. I have to go again and check. True. Currently, we have got an error in the program. I have to check. The digital input should be set to true, but somehow right now it's not shown. I will go to the first set to check whether the buttons are working correctly. Why is it not working? Oh. Why? I have to check. Something is wrong right now. This is strange. This is the first time it happened. It's always when the course starts, then an error occurs. I have to quickly check whether the wiring default has been deleted. This is very strange. I have to check again. Oh, I detected the mistake. I selected the correct module. I'm sorry. I selected the incorrect module. So we have to repeat this process again. I'm sorry. I just remove this module here, go into online mode, offline mode, and select the correct module here. We have to do again the mapping. We just drag this array to the first port of the digit. Oh, it's also wrong. It should be 3. Strange. We have to again do the physical mapping of it.
Yes, and the slot it should be 8053.
Yes, I did a mistake. I'm sorry. I selected the incorrect module. Therefore, now it was not possible to exchange the data. Okay, now the mapping is correct. I have to check this again, 53, 57, 17. And okay, everything is fine now. I will recompile the project again. Download it. Going into online mode. And again into the SPI. And as I already said, the press button switches are directly connected to the channel 8, 9, and 12. It can be shown here. We just activate the press button and can directly monitor the physical status of the digital input channels. In addition, as I already just mentioned just now, moments before, that the first 8 digital output channels are directly connected to the first digital input channels. Therefore, double-clicking these channels, one of the channel will cause the connected digital input channel to show the correct output values. This can be repeated with all the first 8 digital output channels. In addition, the first 6 lights are directly connected to the to the 8th digital input channel just by double clicking this channel, and you can see that the light should, I'm sorry, it should be connected to the digital output channel. This means we have to double click this part to switch on the light and off. And this can be done with all the connected lights. So this is a convenient way to directly control the hardware and check whether wiring has been the wiring was correctly, or whether any other errors has occurred inside the network. The same procedure can be done with the analog in and output module. As I already said, the first 3 analog output modules are connected to the analog input module. Just double click it, set a voltage output of 5, and you can see the analog input channel shows a voltage of about 5. Or you can also enter minus numbers, like for example 10, minus 10, and here you can see the output setting is correct, and the 3rd output channel is directly connected to the voltmeter. We will set an output voltage of 5, and you can see here the voltage meter, it is being set to 5. So the output setting is correct. Now, in the next step, so this is a convenient way to individually test each channel and check whether the connected device, such as sensor or switches or gauges, are correct. And in the next step, we will directly access the digital input and that analog input and output value inside our PLC program application. We will first go into offline mode, go to main, then we will link these coils to a digital output channel. This can be done by just double clicking it and, for example, selecting a digital output, an element of the digital output array, or we just leave the name and we just assign this name, directly link it to a physical channel. This can be done as follows. We go to the configuration user interface, and then we will go to the digital output module, and we will first declare all the coils we want to need to use as a global variable. This can be done by just selecting the global name, the local names, and drag it on top into the global variable section. And this means all these variables can be accessed by all programs in this project. The same we will do with the warning lights, because all the lights we will connect to a coil. Now we will directly link the first 3 alarm lights to the digital output, to the 8th digital output channel, and the warning lights to the following channel. As you can see, now this variable is directly linked to a physical digital output channel, which means we can read the status, or in this case, we can set this output state. In the next step, we will compile this project and download it again. Now going into online mode. This inline function is again active, shows all the current status of each variable. Now we just double click the contact, and you see the lights are starting to flash. The same procedure can be done with the warning lights. We just force the contact to true, and all the lights, the yellow lights, are being flashed every 3 seconds. Now, in addition, if you want to monitor each variable or several variables, we can do it. Can also use a soft scope. The soft scope is a chart which displays the variable values over time, shows changes in values of one or more variables over time. So we will monitor the digital input and output of these lights, of these flashing lights. We will, for example, control the use first sort these in alphabetic order, and then we will, for example, want to control or monitor the first two red lights and then the first two warning lights. We just open the soft scope, select the lights we want to, or the variables we want to monitor, and drag it into the monitoring editor. In addition, we can set for each variable the color by just double-clicking it. The warning lights, we set a different color, blue, for example. So now we can start the monitoring process, just run it. And as you can see, this is not very clearly because the lines are overlapping. We have got the option to show each line or each variable in a different diagram, but just changing the diagram number. And now you can see that the flashing interval. We can also zoom in and zoom out to make it more clearly. And now you can monitor each input and output, or just in this case, the digital output. Another option, and the other useful tool for monitoring the process is to create a graphic control panel. Workbench Graphics allows you to build a simple graphic display for diagnosing and troubleshooting your application. We will show how to do it now. We just right-click watch folder, go into Insert, and select Graphics. We just leave the default setting, and we will the graphic control panel provides several graphic objects. For example, there are different types of LEDs, LED or lights available. Meters are available, which allows you to create your own control panel interface. Switches, for example. So today we will just do a very simple application graphic interface. We just drag a push button onto the user interface, and then we will use a light, for example, a lamp, for example. We just change its size by dragging its size frame. And now we can directly connect each graphic element to a variable. This can be shown, is being done as follows. This contact of the ladder diagram to be connected to this switch. It can be done by directly dropping the name of this contact onto the object, and you will see it will immediately show the current status. And the same can be done with the lights. We will just, for example, use alarm light 1, just drop it on it, and it will show the current status of the variable to which it has been connected. You can also directly from here switch on the contact, but in this case, if you want to do it, you have to recompile the project again. We just go to offline mode, compile the project, download it, go in online mode, and now, as I already said, this switch is directly linked to this contact. So in order to set this contact, just click on this switch, And now the contact is being closed and the lamp starts flashing. So this is the last part, is to show you how to password protect an application. Again, we just leave the online mode, select the tutorial, go to the settings, go to compiling, and here you see that currently this project is not password protected. Just double click this entry and set a new password and confirm the password again. Now recompile this project. So after recompiling this project, it is password protected. We just have to download it to the target platform. So after it has been downloaded, and if you want now to connect to this project or to this remote device, in this case Win-GRAF, the remote device does not allow you. He first requires you to enter a password before you can remotely go online with the target device. Or if you, for example, just want to download a new compiled project, the target device will also not allow you to do, because it's password protected. It will also ask you for a password in order to update or download a new project to the controller. So this is basically the end of today's course, which means today I introduced the main features of the Win-GRAF system and shows how you to configure the Win-GRAF plugin modules in the expansion slots, show you how to implement a simply ladder program to control the IOs, and demonstrated how to use the monitoring tools such as SPI-list, soft oscilloscope, and graphic elements, and show you how to troubleshoot an application. This is the first course offered by ICPDAS for the Win-GRAF series. So therefore, it would be helpful if you could give us your feedback and let us know which specific topic and features you like to obtain further information about or should be presented in one of our future courses. Please scan the QR code and complete the questionnaire on this. Again, thank you for your attention and showing interest in our Win-GRAF products. The forum is now open for question asked, Q&A, and please let us know whether you have any questions about our Win-GRAF products or about this tutorial. Thank you.